Hey YouTube, it's JP Dillon. Today we're looking at a 1952 Stewart-Warner AM All-American 5 clock radio, model 9162. This one is in fairly nice shape. There's very few marks on the cabinet, and as a bonus, it came with its original instruction booklet, which is kind of neat. It's missing the front cover. But it gives you installation, power cord, how to operate. And this one was also designed to control something like a percolator. It's got a very large outlet on the back. Do not use anything that exceeds 1100 watts. It's got a very heavy duty power cord on it. Stewart-Warner was a cool little radio company that made a lot of neat designs. They were based out of Chicago, I believe. Anyway, this one is in need of repairs. Powers up, hums, that's about it. So obviously capacitors and things much like the General Electric that we did a while back. And since we got such a positive response on that, I figured I'd do another one of these AA5 radios. They do come through now and again. And I have a couple in my collection too to get to. So let's get the back off, which looks just like 2 pull tabs and 2 1/4 inch, and we'll see what's inside. So this one still has its little wooden spacers, unlike the General Electric that I had, which I just basically made out of plastic standoffs. But this uses the later generation miniature 7 and 9 pin tubes. So the 35 W4, probably a 12 AV6 back here, 12 BA6, 12 BE6, 50 C5. That's usually what the complement is. And that's true of this one too. Actually, that one uses a 12 AT6 instead of an AV6. This one, they weren't nice like the General Electric, and this does not unplug. This unsolders. And so there's a solder point underneath here, and then there's one here on the tuning condenser. Let's shine a light on this lovely filth in here. It's cool that it has a dial light. It's a shame that they don't, oh, I guess the dial light moves with the tuning indicator. So that's actually kind of neat. So let's go ahead and pull it out of the cabinet and see what the underside looks like. Now the nice thing about this is the entire mechanism, including the clock, comes out, which makes it really handy. As you can see there's our telecron, which probably still works fine. If it doesn't, then we'll have to work on cleaning and lubricating that. This is the generation of IF transformers where you start to see silver mica disease. So hopefully that's not true of this one, otherwise we'll need to do repairs on that as well. Speaker's in good shape, doesn't crackle or buzz. I reattached the back for ease of service, so that's why we're looking like that. And as we can see, this thing is pretty much bone stock except for the lovingly secured capacitor here. I didn't used to see a lot of these Sprague Atom things die, and now they're starting to die, whereas before they didn't. You can see the quality workmanship here, where instead of, using this, of course this could have been cut off. It might have been cut off from something else, and he didn't want to take the rivet out. But I think some terminal strips and a couple of capacitors will fix this, because this is only a 2-section. What is this? 30 and a 50. So, 247s at 160 will probably be fine. It's hard to say what all is completely original. It does look like it's been serviced previously. You've got one couplet here, kind of like a lot of early 50s budget radios had. Save space underneath the chassis. No obviously burned resistors, so that's good. Everything kind of looks okay there. I think that's a choke or a core. Yeah, coil. But yeah, this should be another straightforward thing. So we have to focus on replacing this first, since all it does is hum. And I can illustrate that, but everybody's seen videos on AA5 repairs, so... Oh, and the clock knob just fell off there, so let me put that aside. It was just kind of resting there, I guess, because these other ones, this one's been glued on, it looks like. But okay, so let's get this out of here, and then we'll mount a terminal strip or two and just wire up our capacitors that way. Okay, so I drilled it out enough to where I got the old clamp off. Now I'm going to finish, use a larger bit slightly and drill this out, and then we'll have a new place to mount our terminal strips. And now that I got that out, I realize we are into a bit of a conundrum here, because the speaker is riveted to the front panel, and the place to which I'm supposed to attach the hardware is underneath that pad that's disintegrated. So I need to very carefully get that up, maybe try to reuse it. Oh, and look, original tubes. That's kind of cool, except for that RCA there. Anyways, motion sickness, yay. Okay, so we're gonna get this up, get the old rivet out, pass some new hardware through, and see if we can attach our terminal strips down where the old clamp was. And I'm probably going to need two hands for this, so yeah, definitely going to need two hands. Okay, so let me get to that. Okay, so after some prying up and removal of this tube, I was able to get the pad out, so we'll reuse that. And then we can see there's our hole to pass the new hardware through. And so let me pass a new screw through and attach two terminal strips. Alright, so I got my screw down through the top. I'm trying to thread this up right now. And I'll get this as secure as possible, and then we should have room to mount two capacitors and wire everything up to it. Okie dokie, so we got everything mounted there. We cut the ground lugs off because we're not going to be using those since this floats. And so now we can focus on bringing the proper wiring up to the terminal strips, soldering it in, and then installing capacitors, and then we'll power this thing up and see what it does. Okie dokie, well there she is all wired up, and we've got our 50 microfarad there and our 30 microfarad there. I'm just going to use 250s. There's our shared ground there, which goes back to chassis ground, which is that guy. So now it's a matter of installing the two capacitors, and then we should be able to power up. And actually, looking through my inventory, I just noticed that I do not have two 47s. So I'll be using a 100 and a 47. So I have one 47 and many 100s. 100 is overkill, but even if this filter were to open, you'd still only have minimal hum, so that's kind of like why you have the overkill. Anyways, we're going to put those in there, and there's plenty of room for them, so I'm just going to solder them up, and then we'll go from there. Okay, well I got everything wired up. Got our fresh capacitors under there. I even put the little speaker sticky pad back and secured it with glue. Put the tube back in. And so now we're going to see if it actually operates. I may not be able to tell that with this knob, so we may have to turn it with a pair of pliers. Let's plug it in and see if we got clock. Clock is pretty frozen. I don't hear it moving. Let's see if we turn the dial. Okay, I do get a light. So that suggests that things are operational. Tubes are lighting. That's good. Let's see what we get out of this thing.
Save hours on every trip. Avoid business.
Better see Aaron Rodgers do this.
Acaba cuentas de que .com. Sí. More about your project, or go to our website
Yeah, she's working pretty good.
Most successful enough it's ever been. Just imagine your family arriving for Thanksgiving. Oh my, is this new carpet? Is that a new couch? No,
Okay,
they're
so
not new. I use Zero Res.
the switch works, the radio works. That's a good thing. Our clock is absolutely locked up. I don't hear it running, so we'll need to pull that apart and clean and lube it. This is just really an easy recap job. So we'll replace the capacitors, but I'm more concerned about the clock because the poor Telecron's not moving. Needs all the grease cleaned out. Let's see if we can take care of that. All right, hold on. It is running. I don't know if you can hear it. I can hear it running. I was thrown by the fact that this doesn't have a second hand. The alarm is that guy right there. I thought that was the second hand, but it's not. And it is starting to move a little bit. So let's come back in a bit and see if it's actually kept time. So here it is a couple minutes later. So the clock is in fact moving. So I'm just going to say that it's working properly. We'll run it for a little bit longer and see if it keeps time. And if it doesn't, then we'll still have to take it apart later. But for the most part, these usually are okay unless they've been in a really harsh environment. So I'm just going to leave it as is and see if it keeps time. So now it's just a matter of recapping it, cleaning it up, maybe doing a touch-up alignment, hoping that the silver mica disease isn't prevalent in this set, which requires lots of hours of running it to figure that out, really. So yeah, that's where we're at so far. Okay, so it looks like all we really got to do here, these are two 0.05s, 0.022, 0.15, and then of course the famous across the line cap, which is hard to read the colors on. Yeah, not sure what that would be. Looks like a 0.01 maybe? Hard to tell. All the colors are so faded you can't really tell what it is. I think I'll try looking up a schematic and see what that is. So if we look at that cap on the schematic, it's going from one side of the AC line essentially. And if we follow it, it goes up to pin 6 of the 12BE6 converter tube. So that would be that 100 picofarad right there. So I'm going to change that out just because mica molds have a tendency to die. So at least I know what I need now. Okay, so I got everything I need here. From left to right, we've got our 100 picofarad, 0.022, 2.047s, and a 0.15 I constructed from a 0.1 and a 0.047. So let's get to popping them in. Okie dokie. We'll start with this 0.07 that's up here. 047 rather. Now the leads on this definitely don't have to be as long. These sockets are very brittle, so I'm very hesitant to desolder the pins and solder new ones on. This one I might try tackling here, but the other one at the bottom, I can tell by the discoloration of it that that would be a bad idea. Just grabbing my solder wick that landed on the floor a moment ago. I'm going to see if I can desolder this guy up front here, this top one. I can just feel the flex and the bend. Looks like that was just tacked on there anyways, so. Wonder what the chances are that that's actually a replacement device. They all look stock, but never can tell. And I'm going to trim this back a little bit. Pull the sheathing off, trim that back. And we'll trim this guy off here. Be nice if I had a fixed focal length on this camera. It just tends to do whatever it wants. I have a really nice old Canon HD camera from about maybe the early days of 1080 inception. Wasn't cheap, but it's a bit cumbersome to carry around, so I don't really do that, because then I'd have tripods and different stands and things that would kind of take up the work area. But it sure did have nice quality. These modern cell phone cameras are so convenient and small. There's one side soldered. Trim the excess off that and wrap him around. Now it's hard to tell, based on how this was just tacked in here, whether it actually goes on pin 5 or if it was tacked on to pin 5 and pin 4. So I need to pause momentarily and look at that and make sure. Yeah, schematic shows it only going to pin 5 and 7 only. This is across the rectifier. Yeah, every time I mess with the wiring in there, you can see all the little pins flex inside the socket, and that's just telling you it's old and it's not going to tolerate much. So that's why I'd rather eyelet and hook these things, or J-hook them, than try to desolder and resolder to the sockets. It's just too much risk that it's going to die. Maybe there's more careful people out there that can do it better than me. I'm sure there is. But this isn't a full-on restoration. This is a repair. I really don't do full-on restorations just because I don't really have that kind of patience and skills. I'm sure I could acquire it, but do I really want to? I'm more interested in seeing it run. Yeah, these ones with the amber colored bottom on the IF transformers, these ones love to get silver mica. So I'm going to have to run these ones a good long time just to make sure that it doesn't. Because if it does, we'll be readdressing this. Let's see if I can get me some shrink tubing on that piece that's super long. Yeah, see, I just make a little loop and then bend it up just enough to go on here. But of course now I've made the heat shrink too long. Yep, just a smidge. All these little pieces I cut off I save for other things. I got a whole drawer of these tiny little errors and mistakes. And then I'm going to see if I can bend this upward a little bit. Just to keep it there while I solder it. And then we'll trim off the little tiny bit of extra sticking out here. Get another little piece for this one. I'm going to twist this around the back side while it's in the sheath to establish a mechanical connection. So it's kind of wrapped around the inside there, and then solder it in place. This thing will stop getting in the way. All right. And then we got our .022 up here. The pink thing looks like a replacement. It looks newer to me. I could be wrong. But you just see the pins flex inside of the phenolic there. I just get so nervous about that. That's one of those pucker movements, because if something in that socket breaks, then you have to replace the socket. And that's a big bunch of time. And I don't want to have to invest that time if I don't need to. And that's just moving way too much for me. So I'm going to mock this up. I'm usually pretty good at eyeballing this stuff. Sometimes I make it a hair too long. This one might actually be a hair too short. We'll find out. No, that one's pretty good. And we'll solder that guy in place. And then we'll work on the big old .15. So this is more or less just decoupling to the chassis. In theory, I can just go to this ground lug here, which is the same potential, and just solder between these 2 points. I might do that instead, just as because it's a little bit neater, cleaner. They didn't have tinier parts back then, so they had to work with what they had. Our capacitors are much smaller today than they were then. Give that a good yank test, make sure it's on there. And then I'm just going to wrap this around here. We'll solder that in. And before I do that, actually, let's do a quick check of that resistor. And make sure that that resistor is alive. Reads 0.54, so is that a 0.47? Interesting. Yep, where's that coming off of there? That's off of the clock. And I'm trying to think of what else I could be reading across that might make that look like a dead short. Yeah, maybe I was just touching something inappropriately. That measures 1/2 ohm. All right. Let me check the schematic and make sure that that's what it's supposed to be. Okay, so that is in fact supposed to be a 1/2 ohm. They got it on the between the ground and the clock motor. So I guess it's kind of a fuse for the clock motor. At least that's what it looks like on the schematic. So yeah, I made sure that the new capacitor and everything wasn't shorted. Thought that was a little weird, but it appears to be okay. So we're just going to stick this sucker back in here, solder it up, and trim off the excess. I thought that was a little strange. I'd never seen that before. But if it's how they designed it, if it's how it's worked all this time, I'm just going to let it be. And then we got that 100 picofarad decoupling the AC from the converter tube. And out of curiosity, I think I'll measure this. According to the schematic diagram, it's supposed to be 100 picofarad. So let's see what it actually measures. And here's the new one. 194 nanofarads. Maybe I'm measuring something in the carpet here. That's quite a difference. This is supposed to be 100 picofarad. Of course, let me get my LCR meter. That's probably a better candidate than this. We're going to use my trusty old B&K 875. Still in calibration. I don't know how many times I've used this thing, but it's pretty solid. And we're going to have a little bit of error because of the capacitance in the probes. Yeah, so that measures 120 picofarads, and I'm probably capturing the 20 difference in the probes here. Yeah, so that was dead. Not there anymore. All right, so let's go ahead and change that out. Like I said, mica molds go bad. This is a 100 picofarad at 1,000 volts. I'm sure you could get something a little more, I don't know, safety appropriate, but all right. Yeah, it might be a good idea while we're in here to check for any high value resistors. that have gone way up in value, since we have these lovely examples of the carbon drift-o-matics. Just yesterday I worked on a Packard Bell console amp that had resistors that had gone up about 300% in the driver stage of the amplifier. So out of curiosity here, let's just check a couple of these. So that's supposed to be a 22K. 24, that ain't gonna do much. 100 ohms, 98, that's pretty good. This is what, 1K? So that's 1.5. That's a little on the high side. Looks like a plate supply, so changing that might boost performance a little bit. Let's see, that's supposed to be 24 ohms, measuring 43 ohms. 24 ohms, that's a weird value. Probably kick that up to 27. I think that's our kind of like the fuse for the set. That's in line with the input to the rectifier. Not much else here to measure out. This is all pretty simple, very simple radio. Let's see, we got this one here. I'm guessing that's going to be a 33. That measures 4.5 megs. And that's going between the two IF cans. That's a little high. I'm going to double check and see what that's supposed to be. That is indeed supposed to be a 3.3 meg, so we need to change that out. Okay, so I replaced all but the 1K. When I took the 1K out of circuit and lifted it on one side, it measured 1.1K, so that's 10%. I'm just going to leave that one alone. Not sure why it was getting a slightly higher resistance in circuit. I replaced the 24 ohm with 256 in parallel for 28. I got a new 3.3 meg resistor there. So now we're all set to go. The only thing left to do is plug it in and see how well it performs. Maybe do a little touch-up alignment on the IF and stuff. Okay, let's go ahead and juice it. And we'll see what happens. Oh, I forgot to give this a little shot of contact cleaner, so I'm sure it's still going to be crummy.
He tells NBC7 drug addiction treated as a healthcare issue.
People view addiction as a moral.
Can you really get an expensive product? My neighbor's Xbox for $51 and Xbox for $51. That's insane. You've got to check out Deal Dash. And right now, you can get 100 free bids with your first bid pack purchase. Just send them a text. I'm texting now.
Text bid to 323232 right now.
Uh-oh. Yep, it's got the silver mica disease.
Awarded significant compensation, but the deadline is quickly approaching, so call Stop Clergy Abuse right now. Your call is free, private, and confidential.
All right, so what I'm going to do first to verify is we're going to resolder the pins on the IF transformers and hope that it's a cold solder or something like that, because if not, then I think it was this one that yielded the greatest point of sensitivity. It's going to need to come out and have the wafers removed and then some capacitors put underneath. So I'm going to resolder both of these IF cans real quick, and then we'll try again. Okay, new solder and reflowed all 8 connections between the two cans. Let's see what it does now. I'm not getting my hopes up. Usually when you experience this failure, it's because it's a problem in the can.
SDCCU Visa credit or debit card and pay as credit. You could win double your purchase up to $1,000.
Tappa.
Weekly winners through December 26th. No purchase necessary. For details, visit sdccu.com.
Meet Adrian, fiery spirit, carrying grandma, proud trucker.
I want more
So
than
far, so
4
good.
million miles in my truck. If people knew what I
Since we're at the end of the dial, I suppose we can adjust our trimmers a little bit. Let me grab a tool.
Muchísimas gracias, Hugo. Te seguimos en mi canal de Xbox.
That's better.
Security and defense. But the day of the Lord will come.
Those people have been killed.
Ah,
How precarious this thing can get to a point where, like, uh-oh, are we going to do something?
getting a lot more hum in our 50 C5 or whatever that is. Sure is glowing a bunch. Let me very quickly check something here. Alright, I'm going to check our grid voltage here real quick. This is supposed to be damn near 0. What's the grid pin? Number 2? Let me look. Yeah, the grid pin is number 2, which is where we attach the 0.22 microfarad. As you can see, it's 6 volts. Actually 6.9. Let's see, what's our cathode supposed to be? Cathode is supposed to be pin 1. Maybe I'm just not... Nope, I'm measuring the wrong spot. Alright. Well, the cathode, the grid is still more negative than the cathode. This is the grid, 1.7, and the cathode is 6.9. It should be close to 0, so that tube is internally a little bit leaky. And we got a lot more hum going on.
Oh, did I lose?
Although our silver mica disease hasn't come back yet, so maybe it was just bad solder connections on the terminals, cold solders. I'm just wondering about that nice red glow that's coming from inside of there. And it is toasty, so maybe I'll swap that out too. So now I got a General Electric in there. We're going to see if that produces a change at all. Just gotta wait for everything to come around. Alright, let's hum. Socket's loose. Alright, let me get the ground reattached real quick. And we should have happy voltages now. So on our cathode, we got our 6.9 volts. On our grid, we've got next to 0. That's how it should be. So that tube was in fact defective. And it's better to test output tubes in the circuit rather than on a tester, because the circuit really stresses them more and you definitely reveal it. So this thing ain't,
Question is, what's that number?
we still have our sensitivity and it hasn't screwed up yet.
Robert Solomon had two.
So
Second one, he cleaned his clock. First one, he was off.
no more sensitivity to that, so I'm guessing that it was in fact the connections. So I'm going to pop this back in the cabinet and we're going to call it done. Here it is all back together.
That there may
It's
be
cool
an
that you got your little light here.
That Dr. Hendricks was a largest collection of candidacy. Or is this just a regional thing?
Very cool.
So let's talk NATO. So Article 4 is basically saying we're going to have a meeting.
Alright, so I hope you guys enjoyed this one. It's a nice little radio. And we'll get back into that Fisher as soon as the parts for the power supply get here. Anyways, thanks for watching. More stuff to come.